Good evening, Titans. This is Mr. Sturts. We're on lesson 4.4, and we're going to be talking about scatter plots and lines of fit tonight. So if you go to your student journal, we have 3 definitions that you should have a space for there. Pause the video, write these down. We'll kind of talk about them a little more tomorrow in class. Okay, so get these written down here, these 3. Our core concept tonight is a scatter plot. Okay, and what a scatter plot is it's really a bunch of ordered pairs. It shows a relationship between 2 sets of data, and we're going to use these scatter plots to show trends in the data. Okay, we're going to use correlations, positive, negative. We're going to scatter plots. So this first one says a scatter plot shows the amount x in grams of sugar. So the x-axis shows sugar, the y-axis shows calories, in 10 smoothies. Okay, so part A says how many calories are in a smoothie that contains 56 grams of sugar. So we're going to go to our x-axis, find sugar, 56 on there, trace it up. We see in 56 grams of sugar there. If we trace it over to the y-axis, we see the 270 there. Okay, 270 is our calories. Okay, so we see there are 270 calories with 56 grams of sugar. Part B says how many grams of sugar are in the smoothie that contains 320 calories. So now we're given a y value of 320. So we go up here on the y-axis, trace it over, we see this little dot here. Trace it down to x, we see that there are 70 grams of sugar in a smoothie with 320 calories. Part C says, what tends to happen to the number of calories as the number of grams of sugar increases? Okay, so grams of sugar increases. We look at the bottom there. As the grams of sugar increase, we see that the calories also increase. Okay, we have this little kind of correlation there, which we'll show on the next slide. As the sugar increases, the calories also increase. Okay, so just like the last slide here, we're talking about correlations, positive, negative, or no correlation. Think of these as slopes. Okay, remember with slope dude there, a positive slope is uphill, is up from left to right, it increases. A negative slope decreases from left to right. So same thing with correlations. A positive correlation increases from left to right. A negative correlation decreases from left to right. So looking at these, we're trying to split these points evenly, showing a correlation. The graph on the left, they're really scattered. Okay, the points are all over the place. There's really no trend to those points. So that left one, we're going to say there's no correlation. And the left one shows no correlation. There's really not a trend to those points. There's not a pattern. Okay, but notice on that right graph there, those points generally from left to right, they're kind of going downhill there. Okay, they're going down from left to right. So that shows that we have a negative correlation. Negative correlation there. Okay, just think of slopes. All right, this requires a little more work. We need to make a scatter plot. So they give us a bunch of points. These are actually just XY coordinates. They're ordered pairs. Okay, so for the first one, we have age of a car in years, and we have the value in thousands of dollars. Okay, so if our car is 1 year old, so on our x-axis, we will label all our points here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now our y-axis, let's count by 2s. Okay, over here we have value in thousands, so 2, 4, 6. Trying to write small here. 12. Okay, and we're just going to plot all these points. Okay, so take a second here and plot all of these points. Our first point is 124. So on our x-axis, okay, this is years. We're going to plot the point 124. Okay, and then we have 2, 21. We have 3, 19. We have 4, 18. So we're just plotting a bunch of ordered pairs. 5, 15. We kind of see a trend going here. We're going downhill. 6, 12. 7, 8. And 8, 7. Okay, so we plot all these points. And what it asks is there a correlation here? Now look at those points. It's kind of going downhill from left to right. So like we said before, this shows a negative correlation. Negative correlation, downhill from left to right. Okay, as the years increase, the value of the car is obviously going to decrease. That's our negative correlation. All right, last thing here, using a line of fit to model the data, we have 4 steps we're going to follow. Okay, first we're going to make the scatter plot. Then we need to decide if there's a correlation. Can we draw a line through it? And then that line needs to try to fit that data. That's going to show us a correlation, and it's also going to help us make an equation. Okay, so we're going to do one here. Again, we need to make all of these into ordered pairs. Okay, we have weeks and we have sales. This shows the weekly sales of a DVD and the number of weeks since its release. Okay, we need an equation. We need to write an equation in the end. That's our goal. That models DVD sales as a function of the number of weeks since its release. Okay, we need to find a slope and a y-intercept. We're going to use an equation in slope-intercept form here. Okay, so again, we're going to take a minute, label our axis here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are weeks down here. This is our x-axis. And let's count by twos again. 2, 4, 6, 8, 10, 12, 14. Okay, we're just labeling our axis. We need to go up to, looks like 20 is as high as we need to go. This is sales, okay, in millions. So let's go ahead and plot our points. We have 1, 19, plot a point there. We have 2, 15. 3, 13. 4, 11. 5, 10. 6, 8. Okay, a lot of this section is a lot of graphing here. 7, 7. And 8, 5. Okay, and what it asks us to do, remember, back to our steps. Okay, we need to first see if there's a correlation. We're going to draw a line of fit. And what that means is this line needs to try to split these points. We're not connecting the dots. We're drawing a straight line to where approximately half the points are above the line, half are below it. Try to split it the best we can. Okay, again, there'll be some approximation in here. Okay, but if we drew a line roughly through these points, we want about half the lines to be above it, half the points to be above the line, half to be below. Okay, there's some approximation. So we have this line here. This is what we call our line of fit. Now, we need an equation from this line. Okay, so what we need two things. We need a y-intercept, we need a slope. Okay, so if we look at this y-axis here, that crosses approximately at 19. If we pick out 2 points on our line, let's pick out the point right here. Okay, see this point right there, and oh, it crosses a coordinate down here as well. Okay, let's use these 2 points. We know that this point down here is the point 8, 4. Okay, 8, 4. This point up here is the point 6, 8. Okay, these are our 2 ordered pairs we're going to use. We need a slope and a y-intercept. Okay, we know how to do this. We've been doing this for a long time. Let's find our slope. Subtract our y-coordinates. So we have 8 minus 4 over 6 minus 8. Okay, and what we get there, we get a negative 4 over a negative 2, which we know simplifies down to a, oh, that's why that's wrong. That should be a positive 4. That simplifies down to a negative 2. Okay, our slope, our m, is a negative 2. Now, y-intercept. Okay, we can look at this graph. If we approximate here, look at where that crosses our y-axis. That's our y-intercept. It crosses about 19. Okay, now we can either do that, we can approximate, or we can plug. We can take 1 point and plug it into point slope formula. Okay, you should get roughly the same answer. So if we see our y-intercept is right here at about 19, that's our b, that's our y-intercept. So let's plug it into our formula. We have y equals mx plus b. M, our slope, is a negative 2x plus our y-intercept, plus 19. Okay, and that's our, approximately, that's our answer. Lines of fit, there's some approximation involved. Okay, but that's our line of fit. Remember, draw a line through the points, roughly half the points above, half the points below. Pick 2 points on the line, find the slope, find where it crosses our y-axis, write it in slope-intercept form, and you have your answer. Okay, now that we've finished those, go into your student journal, page 114. Please complete these problems. Again, we don't expect you to get them 100% correct. We just want to show that we have learned something. Okay, try these. We need to attempt these problems. We'll look them over in class tomorrow. So page 114, 1 through 4. Have a great rest of your night. Thanks for watching. We'll see you tomorrow.